The Best of Our Knowledge explores topics on learning, education, and research. Coming up, the spongy moth caterpillar has been defoliating forests in the United States for more than a century. Now, a study hopes to find how the invasive species is affecting populations of the tick that carries Lyme disease. I'm Lucas Willard, host of The Best of Our Knowledge. This is The Best of Our Knowledge. I'm Lucas Willard. The spongy moth caterpillar has been defoliating forests in the U.S. since it was introduced more than a century ago. Now, a new study from the Carey Institute of Ecosystem Studies in Millbrook, New York, hopes to find how the invasive species is affecting populations of the black-legged tick, the animal that carries Lyme disease. To learn more, I spoke with Carey Institute disease ecologist Dr. Richard Ostfeld.
Well, the spongy moth is notorious for undergoing these dramatic population cycles, such that roughly once every 10 years they reach peak population numbers, and they get so abundant that they strip most or even all of the leaves off of thousands or even millions of oak trees in the forest. And they do that in the caterpillar stage, which is active in May through July, which is when there should be plenty of green leaves in the forest and lots of shade on the forest floor. But when the spongy moths undergo one of these eruptions and strip all those leaves, then you get a tremendous amount of light penetration to the forest floor. That changes the temperature and humidity conditions on the forest floor, and we know that that has an impact on black-legged ticks in the stages of their lives when they are sitting there on the ground or under the leaf litter or in soil pores, hunkering down, waiting to activate and seek a host the next time around.
So these ticks actually love a lot of debris or cover on the forest floor. Is this where they actually go through different stages of their life cycle?
Yeah, the black-legged tick spends about 95% of its life, its 2-year life cycle, not on an animal host, but instead on the ground, under the leaf litter, even in the surface layers of the soil, where it's doing pretty much nothing for months at a time. Then it activates and looks for a host at the right time of year, each stage choosing a different time of the year. And so what can cause mortality in the tick is if they overheat or they dry out. Those are the conditions in which, in the lab, it's easy to kill ticks. In the field, of course, they're much more hardy and they're able to escape those conditions. But if it's hot enough and dry enough, then maybe they can't escape and they actually succumb and die.
Now, we're both in the Northeast. Have tick populations, as far as we know, increased maybe in recent years due to climate change? Is there a long-term trend that you're seeing overall that you can attribute to a warming ecosystem?
The answer to that question depends on where you are. So there are places where the ticks didn't occur 10 or 20 years ago because the conditions were inhospitable. Basically, it wasn't warm for long enough of the year. The warm season was too short. And so tick populations didn't establish because they had insufficient time to actually find a host 3 times in their lives, which they need to do to survive and contribute to the next generation. So in the northern parts of their range, so that would be in northern New York, northern New England, into southern Canada, they have been expanding their population size as they move into areas that were formerly too cold for too long. In other parts of their range, there are no directional changes. This varies from place to place, but by and large, the tick populations are doing fine in southern New England, southern New York. They fluctuate from year to year, and that's in part based on climate conditions, but they're thriving, doing well already and not changing that much as a consequence of the continued warming that we're seeing in that area.
Now, I wanted to talk about the white-footed mouse and its relationship with ticks and Lyme disease. Are you also probing how the deforestation caused by a spongy moth infestation is affecting small animals like the white-footed mouse?
We are, and that's because we have been monitoring 6 different populations of white-footed mice on the grounds of the Carey Institute since the early 1990s. So we're coming up on 34 years or so of monitoring. And we know what happens to the mouse populations as a function of all kinds of different changes in the environment, not only spongy moth outbreaks and defoliation events, but also climate change, various weather events, and the production of bumper crops of seeds by the dominant trees in the forest, like the oaks producing acorns. So we will know at the end of the study if and how the white-footed mouse population responds to this defoliation event.
And what is the relationship between the white-footed mouse and the black-legged tick and Lyme disease?
The white-footed mouse is one of the most important hosts in the life cycle of the tick, arguably the most important host, because they are a very commonly parasitized host for the larval stage of the tick. That's the baby tick that hatches out of eggs. And they hatch out of eggs free of infection with the bacterium that causes Lyme disease or virtually any of the other pathogens that make us sick when we get exposed via a tick bite. So the ticks have to acquire a pathogen in order to become dangerous, and by and large, where they get those pathogens, those are the ones that cause Lyme, that cause babesiosis, that cause anaplasmosis. They get them predominantly from white-footed mice, sometimes other small mammals like chipmunks and shrews. And so that's why we call the white-footed mouse the most competent reservoir for infection. It's the place where the ticks largely acquire the dangerous things that can make us sick. But also, the white-footed mice are a very high-quality host for these immature stages in the tick life cycle, meaning that a baby tick that feeds on a mouse is much more likely to survive that experience and be able to develop into the next stage, which is then capable of transmitting that pathogen to us. The mice boost both the infection rate of the ticks and also their population size, and they do that more so than any other host that we've been measuring.
So because the caterpillars will strip all the leaves off of the tree, does it make it more difficult for a tree that year to produce and release fruits that would be food for mice? And second of all, if there is not as many leaves on the ground because they were eaten up by the caterpillars, does that provide less places for mice to hide in an ecosystem from larger animals that might want to eat them?
Yeah, those are great questions. What they're doing is stripping all the leaves, defoliating the trees. And there is almost certainly an impact of oak trees losing their leaves in the middle of summer when they're storing carbon. That's basically what they're doing when they photosynthesize. They need that carbon to allocate into reproduction, which in the case of oaks is producing acorns. This has not been monitored terribly carefly, but we have, again, long-term data, several decades of data on acorn production by these forest trees, and we will be able to determine whether this defoliation event in the summer of 2024, and there was also a slightly lower degree of defoliation in the summer of 2023, so 2 consecutive years of impact, and we should be able to determine to what degree acorn production is reduced. With regard to leaves falling to the forest floor, there are a couple of complicating features here. One is that even though the leaves are getting stripped in May, June, and July, but they're getting converted into caterpillar poop, which actually has a technical term, frass, F-R-A-S-S. So that lands on the forest floor. It is not the same as leaves, but it can be extensive. It's really not a lot of fun, actually, to be doing field work. When the caterpillars are dropping frass, you hear it falling and feel it. It lands on your hat and your clothing. The trees do reflush many of their leaves in the late summer under most conditions. So even though all the leaves have been stripped by August, September, they have regrown some of those leaves, so there still is leaf fall even in spongy moth outbreak years. It's just less than it would normally be, and that could have an impact on hiding places for the mice, which are so heavily preyed upon by lots of different creatures, mammals and birds alike.
Going back to your research and your field work, what will that involve? Is there any work that's ongoing during the colder months, or is this something that's going to kick into higher gear during the spring and warmer months ahead?
Well, we're looking at all three of the biting stages in the life cycle of the tick. So the larvae were active in August and September. The adults are active right now and will be throughout the rest of the fall and even on any warm day in the winter. And then the nymphs will appear next May and June, and we'll be following all three of those life stages over the course of 1 year. Our funding is for 1 year. So we are doing work throughout the winter. That would be the time when we're looking mostly at the survival of the adult stage in the tick, but there are also larvae that we've deployed out in the forest, and we'll determine how well they do, because normally they would overwinter and come out the next year as a nymph. So one of the things that we noticed was that although one might expect with the leaves stripped off the trees in extensive parts of the forest that there would be a lot of light penetration of the forest floor. Indeed, we saw that. As a consequence of that, though, understory vegetation, grasses, various kinds of herbs, and some shrubs absolutely exploded in growth. And because they're limited by light, and normally they get very little light in a closed canopy forest situation. But when the spongy moths have opened up the canopy, the grasses and various other kinds of forbs, dicots, became very lush, remarkably so. And we have measured how much light there is coming in from the forest floor, but also how much it gets through the understory. So it could go either way for the ticks. That's one of the fascinating things about this project. It could be that it gets so hot and dry on the forest floor that the ticks survive very poorly, which would be great for us if we want to avoid tick-borne disease. On the other hand, it could be that this lush growth on the forest floor of grasses and other plants might create a very hospitable environment just right there on the forest ground where the ticks like to hide out, in which case they might survive particularly well. And then we would not consider spongy moths our friends. They would be our enemies because they would be fostering abundance of ticks, which we tend not to appreciate.
Dr. Richard Ostfeld is a disease ecologist at the Carey Institute of Ecosystem Studies in Millbrook, New York. You are listening to The Best of Our Knowledge. I'm Lucas Willard. The Albany Pine Bush Preserve in upstate New York is a unique landscape, home to rare flora and fauna, including the endangered Karner blue butterfly. Part of what makes the preserve a magnet for researchers from around the country is its geology. The preserve is marked by ancient sand dunes, formed by glaciers and intense winds thousands of years ago. In November, geologists came to the preserve to showcase their research and get a tour of the preserve. The Best of Our Knowledge's Madeline Reynolds joined geologists Dr. David Franzi and Dr. Brian Carl for a hike.
The Albany Pine Bush Preserve has some of the most interesting sand dunes in New York State, and they happen to be well studied and protected, and there are programs to continue the preservation and recover the carner, butterfly, other ecological reasons. Dave?
Oh, sure. So I'm a glacial geologist, and I work on reconstructing deglacial history through the Hudson and Champlain valleys, and actually in the western Mohawk as well. So I've been at this for a while, and it just so happens that the geological events that led to the formation of this dune field relate to some of the stuff that I've been doing in the Champlain Valley in a very interesting way. So it's been a real opportunity for me to tie in a lot of regional aspects of my work.
Yeah.
So in the presentations that you both presented, Brian, you spoke about winds. Like you were just stating, David, you spoke about glaciers and things of that nature. I want to know, in your findings, how these dunes formed.
So after the initial glacial sediments were deposited, the landscape evolved in such a way that they were bare, there was no vegetation here. They started to dry out, and that allowed the winds, which were influenced by the proximity of the ice, allowed the winds to pick up that finer sediment and redeposit it in the form of these parabolic dunes.
Brian, could you give me an estimate? I know you kind of weren't sure of the exact wind speed, but could you kind of maybe describe what sort of power these winds had to have to kind of form these dunes back then, thousands of years ago?
I can't tell you exactly what the wind speed would be, to be honest, but what we can